Yeah. So, hey everyone, welcome back to the second module of Deep Learning AI, course AI Agents, where where Andrew talks about reflection as a agentic pattern. So I prepared some slides, just a quick review here. Um, Reflection is basically allowing the agentic loop to think about its own output. So either playing as a different persona or as itself. So you ask the agent to do some stuff, and either a different prompt or the agent itself critiques its own work, which will trigger another round of refinement that will hopefully lead to better results. And it's been measurable that we've seen that it does a lot better. So did anybody complete the assignment for the course? It was a quick one, a very one. So I'll share my answer. So the the assignment was write a essay, like implement an essay writer with a feedback loop where you critique your own essay, suggest improvement points, and this is the assignment that I created. So these are the three prompts that I created. The first one is like you are an article writer, create about the topic with some amount of words. The next one, I asked the agent to impersonate an editor, um, where you would give a critique and uh, rank some three or four bullet points with improvements. And then the refine is it sees the original draft and the improvement requirements and then output something. Now this loop goes on until two things happen. Either I have a limited iteration, so after refining for the last time I output, or the critiquer is responsible to say whether this should see the next, this is good enough to be an output or not. So you can use these two different. I included this image over here because so let me just, before I go that way, so I'm gonna show this here, the results of this. So it's this one. I wish I could increase a bit the size of this. The code increases the size, but not the output. So you see that the first step here, um, I have a draft. This is the first step. This is the output of this one. With some, it's already looking quite okay. Um, Then I have the reflection prompt, which is this one. The output of this is suggestions for improvement. Enrich with concrete example, smooth out transition, make the conclusion more decisive considered. And then the revision has some better grounding. It might have become a little bit larger, so pointing out some examples, some quotes, and then the conclusion also is a little bit stronger on its feedback. So I could have even done more rounds, but that's good enough. And this one is I showed on the last learning group, like the agentic loop. This is the technical graph of the agentic loop with reflection. So you have the environment, and the agent takes some action and observes the environment. And after it observes, it uses self-reflection and external feedback to and experience as well. All of this to decide its next action. It was just a little nice bit. But now let's bring this a little bit contextualized. Well, before I go ahead, any conversation, any topics that we want to discuss here so far? No? This is a learning group, not an exposition of one person. Okay, let's go. So, I thought about contextualizing this um, on GitLab, and we already have a very classic example, even without agents, which is the code review um, flow. So one developer codes, the other developer reviews, and we keep this on a loop until until the reviewer says that it's good enough, right? So we do a code and then a review, and then it's like this. So we already have some level of reflection. Now we could have this as well with the coding agent and the review agent acting on a loop. So, for example, the issue to MR writes a new MR. The dual code review already reviews and requests the software developer agent to already implement the changes. And they continue this on a loop for three, four times, or until the dual code review think it's good enough, and then it sends to a human reviewer. We can even improve this on with meta reflection. So suppose that I had this code review loop happening for an agent. After the review is finished, I could have the agent itself thinking for itself, how could I have done it better? What improvements, how could I have avoided, what caused a comment from the human that I should have caught earlier? This could be written into agents.md or agent slash, I don't know, code review.md as a memory of learnings that it could take to the next place, right? So this is a little bit an advanced form of like a more advanced form of reflection where I am adding memory, where I'm adding continuous learning for this and so on. Oh, um, and Um, finally, this is even a more advanced. So imagine that you had multiple agents running code and review, each one thinking, each one writing, the improving a collective agents.md, so a collective memory where agents can self-improve over time. What would be It would be really interesting to see the evolution of agents.md. Would they create their own language where they talk to between each other? Like, would after 5 months, would this be understandable by humans? Or does it become its exclusive language? So this is a different setup. I have some comments on the slide. Ani, you had one comment? Do you want to verbalize?
Yeah, so certain models are better at certain tasks. So back to your example, creative writing, let's say GPU
Mm-hmm.
4 versus proofreading, other models maybe for just just better at that. So incorporating that into the loop, it's a, yeah,
Yeah.
it's just a nice.
The author even mentions that since models are trained on different data, they can have different perspectives. Kind of like talking to a coworker, and then they bring up some idea that you haven't thought before.
Yeah, exactly. Yeah, I wonder if that setup could also be applicable to the GitLab agents
Yeah.
and exactly code review versus code generation.
Mm-hmm.
Because
Yeah.
currently it just we have one model selected, and that's all. Yeah,
Yep.
just bring kind of whether also the second idea is whether adding this type of reflection could be like an option for user. Because now that we have usage billing, obviously we want to be mindful of the number of calls, but like I
Mm-hmm.
wonder if you be more control as to, oh, if you want more reflection to, have this additional loop, you can have an option to set. So obviously you have more calls, but then the results could be better. I don't know, just throwing
Hmm.
out some ideas.
Yeah, that's a good point. Like, who pays for this, right? Because you might make the argument that over time it reduces the number of tokens that are used because it improves the first. It becomes closer to zero shot. Ideally, the number of loops, if you have learning on, would decrease over time. But if you just implement this loop over here, then you the only promise you have is better results, but at a an additional cost that we have. Each loop adds another increased cost to it. So we cannot just do it without like the with our current approach. We cannot anymore just implement this. We have to think of the impact.
Yeah, I guess maybe if that is the implementation path, it would be adding something like what you said next, which was the meta reflection. Then that thing would, ask itself whether the cost was worth it. Anyway, I'm just throwing out ideas. I don't know if I'm detracted from the paper and the course module.
No, it makes sense. It's like there's something that it's theory, and but now it bring it to reality. Like ideally, we would have like 1,000 agents all doing the thing, and we wouldn't care anymore. But there are costs around it, like that we need to consider when bringing this to an actual product, which is what we do.
Yep. Yeah, that's the end of my comment. Thank you.
Yeah. Newsweek, you had Newsweek, you had a comment as well.
Yeah, in his in the original slides, he cited that reflection paper, and it looks like it reflection helps significantly on some tasks and not others. For example, it doesn't really improve math reasoning or code optimization. So I was wondering, like, is it part of some general trends that reflection improves on, or is it just the result of the specific model that the paper used?
I think it's this graph, right? That we see some improvements, or is it programming?
Uh,
Let me find the limitations.
Let me
Yeah,
see.
it's an
Let me dig it up.
optimization. No, no, no. Yeah, I'm trying to find where like approach, test of reflection. I need to read this. Okay, so here is one. So on Python, the reflection does not really improve anything. For some, it improves considerably. So these are the two most basic Python programs. Um, on human evolved dataset, it does considerably better, but on the most basic Python problems, I think it's the name of the dataset, it doesn't do a lot better. Which is surprising to me, considering that it's actually very good at coding. So at least what I do when I'm writing code with Duo, I have Duo code review itself before I push the first commit, and usually improves the code base. But yeah, it might be the model that they use. It's just this is a GPT-4 model. Maybe we can do something different. The interesting thing is that this is from 2023, this paper. So this is really new, actually, um, considering everything that is going on. This is from October 2023, so it's a little over 2 years old right now. It's really interesting to see this kind of new
Well,
paper making evolution. Sorry?
that's interesting. There's another paper that I think I was mentioning in another paper. I just sent it in the link there.
Uh-huh.
So that one has the specific slide that Andrew Ng on page 5.
Page 5. This
Oh
one?
yeah, that chart there. Yeah.
Ah, okay.
So if you look at like math reasoning and things like
Mm.
that, like adding self-refine doesn't really change it. And then if you look at like code optimization, adding reflection doesn't change it. But then things like code readability, it adding reflection changes it significantly. So that's the slide I was referring to. Yeah.
So it might mean that it's better at subjective or subjective qualities or human qualities rather than the exact solution of things. So both of them, so I'll be bringing the code review. Both of them, like the original code would already pass the tests, but the reviewer gives requires different way of reaching the same solution, right? So maybe that's why it's like 6.4.1. They are almost exactly the same here,
Yeah,
right?
that's a good point. It's like it's I guess objective versus more subjective. Optimization versus readability. Yeah.
So there are different solutions for the same thing in this case. And then we get to choose what. But in some, like only the math reasoning was bad. The rest one, even like 9 points is already something nice to see. Like 23 on ChatGPT, 30 on GPT-4. So those seeing those things is we see a lot of impact. And Andrew also mentioned that this like if that gets even better if we include output like external data, external feedback, like pipeline errors, pipeline I don't know, number of database calls and things like this. So then the agent has even more feedback to work on. Any more comments? Any more ideas? Okay, I added some other. I'll share this later, but there are some this the paper. I'm gonna add also this paper over there. If anybody wants to extend the learning to other places, so there's a nice reflection paper blog post on Hugging Face. I think it's yeah, and it goes over all of this as well. There is by Andrew Ng. There's also a blog post to read on. Um, and yeah, that's it. That's what I had today. Any final comments? Ideas? Discussion? Cool. Awesome then. I'll stop sharing now and I will turn off the recording. Where's more record? Stop recording.